Right, so assignment, I want a good grade, right? How do you get a good grade? Well, generally you follow the instructions, but I think you know that when you reach PGT, postgraduate taught, that you do have to, to a certain extent, think of yourself, right? Now, this is supposed to be kind of reflective as to what you would do in industry, so the report that you produce will document your findings in making and producing the board that you make. So really, what did you learn out of it, I think, is one of the biggest takeaways. So not I built it, it works. What does that mean? I mean, it's just meaningless, isn't it? I built it, it didn't work, you know. What does that mean? But you can have certain things that don't work, but you can diagnose what happened and have a lengthy discussion as to why it didn't happen, and you can have a first-class report. So it rather depends how you portray these things. Okay, I'm not going to swing the camera around, but when you go on the CE721 webpage, you know what you're doing. You're building, I will swing the camera around briefly, you're building that circuit, remember, aren't you? That's your requirement. Where's the locking pin on this one? I don't know. So you're building that circuit. We spoke about the ability to be able to expand that, so you can have more LEDs coming from the centre, and you can have more LEDs going around the arc if you want. Will you get more marks for that? Probably yes, because it requires a little bit of additional thought. So there's a couple of extra marks that you can pick up there, and anyone's going to hold me to it and say, well, quantify how many marks. No, I will not, because I need some flexibility in marking this, because what am I looking for? I know you're all good students in here, I realise that, because you've turned up when others are away. But I need to distinguish between the good, the bad and the indifferent. So someone that hasn't put much effort in, that's going to be reflected in their report. Okay? So I need to give myself some flexibility on that marking so that I can take marks away as well as award them. Now, report guidelines and grading criteria, again, this is on the web page, which is under assessment, and report guidelines, grading criteria, and here it is. So, just zoom in so you can see that a bit, I'll read it out for the camera. What should the report look like? Well, there's a little description there, but that's going to be of the basic form, I write it on the board, so abstract. Somebody tell me what an abstract is. What's an abstract? Time, that's abstract. But that's not what I'm talking about here. So an abstract inside a technical document is this report examines the, and see, people are going to start writing it down now, aren't they? This report examines the design and implementation of an electronic VU meter from a fundamental circuit that was given beforehand. That tells me what the whole report is about. I'm not interested in how many LEDs it's got. I'm not interested in the fact that you're using xenodiodes on your chain and all the rest of it. That's immaterial. So the person picks up your report and thinks, I'm a psychologist. They read two sentences and think, that report's not for me. That's what the abstract does for you. Quick, brutal, lets you know what's actually happening. Introduction. So now we're in a bit more detail. So in the introduction we're going to talk about things like, well, we used multi-sim, didn't we? And we used multi-board, and we designed using surface mount and through-hole components, our experiences of that, these kind of things. Potentially some of the good things about multi-sim, some of the shortcomings. Then a little bit about the circuit, and that's where you'd start to introduce this. So what's happening there? You're lighting up, well, what is a VU meter to start with? That's the kind of thing you'd answer in a couple of sentences. It's a thing that measures power of an input wave, in this particular case a sound wave. So setting the seeds for the rest of the report. The next one, your main body. Now please don't call it main body, that's not what it's meant to mean. It's just where all of the core stuff that you've got, that's where you're going to find your printed circuit board, that's where you're going to find your analysis of your results, all of that kind of stuff, the meat of what you've done. Okay, the bit that you probably find the easiest to talk about, which is what you've done on the simulator, okay? So you shouldn't find the main part actually that difficult because you've done all the experiments. Now, conclusions. We had a great time in 721 and we built a VU meter. Am I going to be impressed with that? No, not at all. Not at all. That's a real cop-out. During the design of this VU meter, it was realised that the chain could be extended almost forever. So the VU meter could have as much complexity as it wanted in the number of LEDs and the number of vertical LEDs, making it look more like an analog meter. If I had more time, I would have spent more time on this part. Conclusions, okay? Multisim is a good simulator, however, it couldn't model the circuit in its entirety, so therefore I had to split it